Hello everyone, this is teacher Benard from Trinity College in Abingo. I've come here today to teach you chemistry and its compounds. I hope you are staying safe at home, sanitizing, putting on your masks, avoiding unnecessary visits. Chlorine and its compounds. What is chlorine? Chlorine is a diatomic gas and it is an element in the periodic table which is in group 7 of the periodic table. It normally exists in salts of the sea such as potassium chloride and then sodium chloride. At home we can find it as sodium chloride, the common salt we eat. How do we prepare chlorine gas in the laboratory? In the laboratory we can prepare chlorine by oxidizing concentrated hydrochloric acid. There are two oxidizing agents we can use, that is potassium manganate 7. They are purple crystals, and then manganese 4 oxide also. We can use it. Using potassium manganate 7, we can set up our apparatus as below. We can put concentrated hydrochloric acid in a tap funnel, and then we put potassium manganate 7, those purple crystals, in the flat bottomed flask. And then we set up just the apparatus, the way you are seeing there on the screen. How do we describe the preparation of the gas? The preparation of the gas, normally if you know the diagram, you can easily describe the preparation of the gas. You must talk about the reagent and the container, the condition for the reaction, and then you must show how we purify the gas, how we dry the gas, and then the mode of collection of the gas. For example, here I'm going to say concentrated hydrochloric acid. Where is its container? It is coming from a tap funnel. Concentrated hydrochloric acid from a tap funnel, someone else may call it the dropping funnel, is added to potassium manganate 7 in a flat bottomed flask by opening the tap. The next thing is that the reaction is going to take place, but the reaction takes place at room temperature. So I'm going to say the reaction takes place without heating or at room temperature, producing a greenish yellow gas, which is chlorine gas. And then after producing chlorine gas, the gas is passed through water. Where is the water? The water is in the wash bottle. After passing chlorine gas through water in the wash bottle to remove hydrogen chloride gas, then we pass it through concentrated sulfuric acid for removing water vapor or for drying it. And then we can collect this gas by downward delivery. Since it is a heavy gas, it is denser than air. So you must be as smart as that, just be concise and precise. You can describe something like this. Just brief. Talk about the reagent and the container, and then you must also know the equation for the reaction. This equation for the reaction can always be mastered by remembering or recalling. Some people call it cramming the 2 on potassium manganate 7 and then the 16 on the hydrogen chloride gas. When you're using manganese oxide, we can set up the apparatus as below. Still, we can have our manganese oxide in the round bottomed flask, and then we can have our concentrated hydrochloric acid coming from the tap funnel. I did not label it here up, but I labeled it down. Now, since this reaction requires heating, we use a round bottomed flask, and since it cannot sit on its own, we have to clamp it. Now, how shall someone describe this? Someone will say concentrated hydrochloric acid from a tap funnel is added to potassium manganate 7 crystals in a round bottomed flask. What happens next? The reaction occurs, but on heating. The reaction occurs on heating, producing a greenish yellow gas, which is chlorine gas. This gas is bubbled through water to remove hydrogen chloride gas, and then it is bubbled through concentrated sulfuric acid to dry the gas, and then it is collected by downward delivery since it is denser than air. So someone can briefly describe the preparation as shown there on the screen. Then the equation for the reaction you must also know, and of course the balancing, that is the equation for the reaction there. What are the physical properties of chlorine? Chlorine is a greenish yellow gas. It turns a most litmus paper thread and then bleaches it. It is a bleaching gas. Actually, it is applied normally as a bleaching agent. It is sparingly dissolved in water. We have already seen it is denser than air, and it is also poisonous. So experiments about it must be done outside class or in a fume cupboard. What are the chemical properties? Chlorine is so rich in its reactions, and it is normally acting as an oxidizing agent. Oxidation is the removal of hydrogen or addition of oxygen, but chlorine normally reacts as an oxidizing agent by removing hydrogen. It removes hydrogen from substances that have it. It can also cause the oxidation state or the valence of ions to increase. That's also oxidation in terms of electron transfer. Because oxidation in terms of electron transfer is the removal of electrons. So let us look at the reactions in which chlorine is acting as an oxidizing agent. It can react with metals, it can oxidize metals to their salts, it can oxidize compounds that have hydrogen, it can oxidize solutions. Also, for example, solutions of iron too, as we are going to see. Reaction with metals. It can oxidize sodium to sodium chloride, and the reaction is vigorous, and then the observation is a white solid of sodium chloride formed. Magnesium must be burning. For sodium, the reaction may occur even without heating. It is spontaneous, meaning it can occur vigorously without even heating. Magnesium must first be heated, and then to react with chlorine, also forming a white solid of magnesium chloride. Copper, when heated, will react also with chlorine to form copper 2 chloride. Copper 2 chloride is a grain solid. Reaction with metals, we are continuing the reaction of metals still. Iron. Iron reacts with, when you pass a stream of dry chlorine on iron, what happens is that iron first, but as long as the iron is heated, when chlorine is passed over heated iron, iron first glows red, and then it reacts with chlorine, forming brown fumes of iron 3 chloride. This reaction, we can apply it in the preparation of chlorine and the preparation of iron 3 chloride by direct synthesis. Direct synthesis means the combination of elements that are in a compound by directly reacting them, and then you form the compound. So when we directly combine chlorine and iron, we can get iron 3 chloride, and we can use this apparatus. We get chlorine, we pass it through anhydrous calcium chloride for drying it, and then after it dries, we can pass it over heated iron filings. You can see the iron wire on the diagram. When we heat it, it will react with chlorine to form brown fumes of iron 3 chloride. Iron 3 chloride can sublime. So once, because of the heat, it will sublime and then goes to the collecting vessel. The collecting vessel is that horizontal flask you're seeing, where we have the labeling of iron 3 chloride. Now, what is the purpose of the guard tube? Now, some chlorine does not react with the iron wire, the iron filings or the iron wire you are seeing in the diagram, and we must let it out of the apparatus. So we connect the guard tube to help us pass out the excess chlorine that did not react to the atmosphere. But as we let out excess chlorine to the atmosphere, most likely air, which is having water vapor, may enter into the vessel having our iron 3 chloride. And iron 3 chloride is highly deliquescent. It can easily absorb water from the air which is entering through the guard tube. So what we do to remove the water vapor from the guard tube and from the air, to remove the water vapor from the air, so that it does not reach the iron 3 chloride, we put anhydrous calcium chloride in the guard tube. That anhydrous calcium chloride in the guard tube is to remove water vapor from the air, so that water vapor does not reach iron 3 chloride to cause the crystals to dissolve, so that it remains dry. So using the description I've given you, I want you to describe using a label diagram how dry iron 3 chloride crystals can be prepared in the laboratory. Reaction with nonmetals. Chlorine can also oxidize nonmetals to their compounds with chlorine. For example, it can oxidize phosphorus. White phosphorus, it burns spontaneously in chlorine to form a white fumes of phosphorus trichloride and then phosphorus pentachloride. Those are white fumes. With sulfur, we get a yellow or orange liquid of disulfur dichloride. The equations are there. Hydrogen burns also in chlorine to form hydrogen chloride. Hydrogen chloride are white fumes. Reaction with turpentine. Turpentine has a formula C10H16 and it is a liquid normally used as some of the components of liniment. Now, when you get turpentine and pour it into a gas jar full of chlorine, what happens is that the turpentine glows red, and then finally black particles of carbon and white fumes of hydrogen chloride gas are formed. Now, in this reaction, you will note that in this reaction, chlorine removes all the hydrogen from carbon from one turpentine, and then you form black particles. Like this reaction shows a high affinity of chlorine for hydrogen and a high oxidizing power. Reaction with hydrogen sulphide. Also, chlorine will remove hydrogen from hydrogen sulphide, and then you get hydrogen chloride, which is white fumes, and sulfur, which is yellow powder. Reaction with methane, you will also realize that to remove all hydrogen from methane, and then it forms black particles of carbon and then white fumes of hydrogen chloride. All these reactions illustrate that chlorine is a powerful oxidizing agent because it can remove hydrogen. And then reaction with water. Chlorine reacts with water to form two acids, that is hydrochloric acid and hypochlorous acid. Hypochlorous acid is so unstable and so oxidizing and is actually a bleaching agent, as we are going to see. Now, how does chlorine bleach? Chlorine reacts with water, forming hypochlorous acid and hydrochloric acid, as we have already seen. Now, if you bring a ready flour or a moist bullet mass paper and then you put it in a gas jar full of chlorine, the moist bullet mass paper will first turn to red and then finally it will turn to white, or it will be bleached. Why? Because chlorine first reacts with water to form hydrochloric acid and hypochlorous acid. These acids cause the litmus paper to first turn to red. And then hypochlorous acid is a very powerful oxidizing agent and is so unstable. So it oxidizes the red dye, which is in the red litmus paper, to a colorless compound, and thus bleaching it. The same story or the same thing will happen to the colored flour. What happens when we expose? Because we have already seen chlorine in water forms hypochlorous acid and hydrochloric acid. The mixture of chlorine and water is what we call the chlorine water. So what happens when we expose chlorine water to the sunlight? Some reaction takes place, as we are going to see. On exposure to sunlight, chlorine water, which is a pale yellow solution, it decomposes. What decomposes actually in the chlorine water is hypochlorous acid. It decomposes to give us hydrochloric acid and the oxygen gas. So we observe, so due to formation of hydrochloric acid, the pale yellow solution, that is chlorine water, it is yellow because it has chlorine, but now it has chlorine and then hypochlorous acid that was formed due to chlorine reacting with the water. But now it turns to colorless due to formation of hydrochloric acid, and then we see bubbles of a colorless gas, and that's oxygen gas, due to hypochlorous acid decomposing to form oxygen gas. We have already seen the bleaching action of chlorine, and then reaction with iron 2 chloride solution. This is another example of oxidation reactions of chlorine, but this one is in such a way that chlorine removes electrons from iron to ions. I want you to be so keen about that. In this reaction, chlorine is again acting as an oxidizing agent, but it is oxidizing in such a way that it is removing electrons from iron 2. I want you to note that the green solution turns to brown when you bubble chlorine gas through iron 2 chloride solution. But why does that happen? Because iron 2 ions become oxidized to iron 3 ions by chlorine gas. And then also chlorine gas can oxidize a solution of potassium iodide to iodine. Now, this one is what we are used to as a displacement reaction. You know, chlorine is more reactive than iodine. or even bromine, and therefore it can displace them from their solutions. That is the literal meaning. Displacement is the literal meaning, but what actually takes place is the oxidation. You can see that iodine, the iodide ions in potassium iodide, lose their electrons because you can see that in this side, like of the equation for the reactants, iodide ions are negatively charged. So they lose the electrons and they become iodine. That iodine which is formed makes the solution to become brown because iodine is brown in solution. That's an oxidation reaction. Chlorine has oxidized iodide ions, but we can also literally say it has displaced iodine from its solution. The similar reaction occurs to bromide ions in potassium bromide. The bromide ions become oxidized to bromine, and bromine is red in color, and therefore the solution turns to red due to formation of bromine or due to displacement of bromine from the solution of potassium bromide. A reaction with alkalis. When chlorine is bubbled through a cold solution of sodium hydroxide solution, the color solution turns to pale yellow. This is due to formation of sodium hypochlorite. Sodium hypochlorite is a pale yellow substance used in bleaching. Therefore, due to its formation, it makes the solution to be pale yellow. The ionic equation can be written as that. Those people are scared about ionic equations that we are writing here in this presentation. Don't worry, we are going to elaborate more on ionic equations in the next videos. For potassium hydroxide solution, the equation is the same. We get potassium hypochlorite, which is also a pale yellow substance, and therefore the solution also becomes pale yellow. So if you're asked what is observed when chlorine gas is passed through sodium hydroxide solution or potassium hydroxide solution, the answer should be a pale yellow solution is formed. What are the uses of chlorine gas? Chlorine gas is used in the paper industry and the textile industry to bleach. It is a bleaching agent, and therefore it is used for bleaching in textile industry for making clothes, and then also in making paper for bleaching wood pulp. It is in the manufacture of hydrogen chloride on a large scale in the industries by reacting hydrogen gas with chlorine. It is used in water treatment to kill microorganisms that are dangerous to the living organisms. It is also used in the manufacture of polychloroethene or polyvinyl chloride. This polyvinyl chloride is the substance used to make wire cables, insulating wire cables in our homes. So in the next video, I'll be explaining hydrogen chloride because it does not mean that chlorine and these compounds is done. We still have other compounds of chlorine, and that is hydrogen chloride, hydrochloric acid, and then also have the chlorides, for example, sodium chloride. So in the next video, we shall elaborate more about that. Please, for more resources, visit the link below. Thank you for watching.